Hello everyone, welcome to Green Academy. Today we are going to look at the forces and dynamics of a car on a slope. The question reads, a car of mass 1500 kilogram is moving up a slope that is inclined at 14 degrees to the horizontal, and the car is moving at constant velocity of 15 meters per second and has a resistive force of 1000 Newton acting opposite to its motion. So, what is the thrust provided by the car's engine? Now, as we can see the diagram below, it shows the car moving up the slope. Now, it will be good for us to label the forces acting on the car. So, we have the weight of the car, which is acting vertically downwards. This is the weight. And then we have the normal contact force, which is perpendicular to the surface of the road. And they say there's a resistive force of 1000 Newton, which is we can call it F, the drag force. And of course, there's going to be the engine thrust. Let's label this T. Now, these are the forces acting on the car. Now, what we are interested in is the thrust. Now, there are some key things to note that the car is moving at a constant velocity of 15 meters per second. That tells you that the acceleration is 0. Acceleration up the slope is 0. Now, what we can do is we can resolve the weight into two components. Remember, the weight is acting vertically downwards, but there will be a component of the weight along the slope. So, if you have to resolve the weight along two components, one perpendicular to the slope, okay, this is the component perpendicular to the slope, and another parallel to the slope. So, what we have here is the two components, and do note that this angle is actually, if you do your trigo, this is the same as the angle of inclination, which is 14 degrees. And if you get your trigo right, the component here is W cos theta, and the component here is W sin theta. So, what we have here is the components of weight, okay, which have been resolved along the slope. Now, we are only interested in the forces along the slope because what we are keen to find out is the thrust. So, we write an equation. Let's make this a little smaller, give us a bit of space. Now, the thing to take note is this angle theta is nothing but this angle 14 degrees. So, now to write the equation, we have along the slope, we have the thrust minus the opposing force of 1000 Newton minus W sin theta, which will be equals to ma. Now, we have already written it out that the acceleration is 0, so this is 0. So, the forward thrust is equals to the opposing force plus the component of weight acting downwards. And we can put this in 1000 plus mg sine 14 degrees. You sub in the total values, 1000 plus 1500, which is the mass, 9.81 sine 14 degrees. You solve it, you get 4560 Newton, and you can also make it to 2SF, which is 4600 Newton. Okay, so we got the thrust, and this is how you solve this question. Hope this helps. Thank you.